Today I'm going to tell you about the latest video number 9 in the Electronic Lab Notebook series, where I'm going to continue this idea of extendability, and we're going to use that to monitor, run, control an Arduino device, and I'll show you a little bit about that in a minute. So I'm going to switch scenes, and hopefully this is clear enough. The lighting's not great, but this is a little Arduino Uno device, and it's got three LEDs over here, and there's a temperature sensor over here. And if I start touching it, then as it warms up, you'll see the 3 LEDs light up. They light up at different temperature levels, and whether my hand is hot enough there is hot enough to get to the 3 levels. And now it's going to cool down like that. Now this is on YouTube, and that sort of shows you what is possible in here, but we aren't going to have our notebook on YouTube, and so we're going to explore a couple of options in capturing this information, capturing some data that's there. So I'm going to switch back to Emacs here for a minute and scroll down here and see what kinds of things can we do. Let me see if I can make this maybe a little bit smaller. So just so the table fits on there. There is a command line utility that we can use to list the boards that are on here. And so the device that I want is the one that's plugged into this USB. I actually have it plugged into my keyboard. And so this is how we find the identity of our device. And you'll need some way of knowing how to address a device. Probably it's plugged into USB. It's also possible that it's Bluetooth. And I've ordered a Bluetooth, Wi-Fi, Arduino, and a future video will explore running a Bluetooth device. But this one is plugged into the USB. Now, I wrote some code. It's adapted from OB Arduino. That comes from org mode and does some kind of scimax specific things. And one of the things you have to do with a Arduino is load code onto it. And there is a command line utility for doing it. But what I wanted in this example was something a little bit different than the literate programming I used on the ADA Fruit device the other day, where I would upload, I could save a Python file to a path, and that would modify it. What we're going to do here is, instead of using the literate programming where I write the program in my notebook and then tangle it to that path, we're going to just write directly to our device by executing the source block. And maybe it's worthwhile taking a quick peek at what happens in here. So it's quite short. I leveraged the org babel execute. So this is going to make that source block be executable. So when I run it, it's going to run this function, and it's going to get the port in the board. It saves the code to a temporary file, and then it runs the command line utility for me, and that's how we upload things onto the board. Now you can see this is sort of a complicated looking command in my opinion. This is not something I will remember how to do, and I would have to look it up every single time. But with org babel, I will always remember Control-C, Control-C to execute it. And so this is just a convenience for myself to take that code and upload it. Let me add a little overlay here. I thought I had an overlay here. And that's strange. let's see if I can just add. I don't know if I can change this while I'm editing. Alright, well, I guess I will switch to this maybe, and then I'll tell you what I'm doing in Emacs. And so in Emacs, I just come to this this source block and I type Control-C, and you should see it just blinked like that right here, right around here, and that was the code getting uploaded. Okay, so let me walk through the code kind of briefly what this does. This is setting up a baseline temperature of 25 degrees. It's a little bit warm here, and then that's in Celsius. And then we specify some pin modes that are output, and we set some digital things to low. And then we are just reading a sensor pin for the temperature, and then doing some calibration of time, converting this sensor values into voltage, and eventually down here turning those into a temperature. And there are some serial.print. I'm going to come back to that in a little bit. Then there's just a little bit of logic here that if the temperature is less than the baseline, then we set the LEDs to be low. If the temperature is in this window, then we set the first one to be on. If the temperature is in this window, we set the second one to be on, and if it's above that, we set the third one to be on. And then we have a little delay for 2 seconds, almost, and that's all it does. All right, and when I run this, I will delete this and run it again just so you can see what happens on the Emacs side, and it will tell me that it did a new upload port. All right, so now I can do a couple of different things here. Maybe I can switch to the desktop mode and show you what happens over here. So I can do Control-U, F10, that will minimize Emacs and take a picture. And then I can get Emacs back. Like so. And now it's going to be unhappy and hang. I hate that. I'm just going to move this off to another screen and see if I can do it from there. All right, so that's not a great picture because I want to see the text in there, because later I want to see if we can find it. Okay, so now I have a picture saved, and that's okay, but and I could save a picture if I was touching it and seeing something like that, but it's not quite as good as I would have liked. So next I'm going to try to save a video, and I'm going to save the video, and let me move this back over here. I think it'll work like this. So from here I'm going to insert a video edit mark, and it opens up QuickTime. I want this one to be what we use. Let's make sure we have that set. And the microphone, we'll use the Yeti microphone to make sure we get some sound. And then I'm just going to press record. Now I can talk, and I'm going to read the hashtag Arduino banana boat. That's also because I'm going to see later if this audio gets transcribed and becomes searchable. So now this is the device. I'm going to put my finger on here and see if I see it turn red. There's the first one, second one, and third one. All right, now I can take it off and watch it cool down. It'd be really interesting if there was like a clock in this video, because then you would be able to get a better sense of time. And then if I look up here in Emacs, it says press Q to quit. So I'll press Q, and that should have inserted a note. example of how the device works. And now that inserts this movie, and I can press enter on this and it should open this. Now I can talk, and I'm going to read the hashtag Arduino banana book. Perfect. Okay, so I like that. This is pretty, anything, again, you can wire up to QuickTime, and it will be able to do that. Let's save an audio here too, because... Alright, this is an audio version of hashtag Arduino banana boat running the 3 LEDs with the temperature controller. That's all for now. Alright, so I'm going to say that something is buggy in how it is putting these in. Now, it may be taking a minute because, oh, yeah. In principle, this is making a tooltip that takes this AIFF file and is transcribing it so that we can read it. There it is. This is an audio version. Asks for it. We know banana boat. All right, I did see banana boat in there. But now I need to give it a minute to get off that. I'm probably going to have to take this tooltip off because it's a little bit expensive, and also you can't see it in here. Okay, we got out of that. I'll fix that. Make a note here. All right. Now, it also would be interesting to note that there is actual data coming from this device. So here, the device, you might remember in the code, had all these serial.print lines. Well, those are writing to the serial port. And let's see, we're on the desktop. So let me get the QuickTime back up. Make a new movie. There it is. So now you can see this data. This is the time, a sensor reading, I think a voltage. This is the temperature and a state. So it's in the low temperature state here. I can press this. You'll see the temperature goes up to 28 and then to a little over 29 and then over 30, right? And then we have, we can watch it go back down. And this is actual data. It's not in the notebook yet, but as soon as it goes back to 0, what I'm going to do is just highlight this and figure out how to, I'm just going to copy and paste it. Maybe I'll just do Control X and wait for that to cool off. Really taking its time. Like I said, it's warm up here. There it is. All right, so Control X, H. Usually that works. The serial is a little bit strange. And let's see if I can maybe paste it. Nope. All right, this is going to take a little creativity. I don't love the serial port. It's a very old way of getting data. So let's just try that. And that's all of the data. And then I'm going to go ahead and kill that to make it go away. Okay, so this is not the most reproducible kind of data, and I do have to do a little bit of cleanup work here. But now we could save this to a file and then plot it, or do something different with it. But at least it is now small enough that it's in here. And if I wanted to, I could have saved that into a CSV file and then read it into something else. That's probably what I should have done. Let's try that again. Hindsight's always 20/20. Let's see. With temp file data.csv, insert okay, so whenever I feel like I'm ready, let's put some more data in there. Let that cool down. Might seem like we're doing some, mundane or kind of silly things, but being able to access things like serial ports, being able to access data, being able to capture all of this can be really important when you're trying to explain to somebody what's happening, or to yourself what's happening, if it's working the right way, etc. And let's check that we got data.csv. That has some cruft in it here. I might choose to delete. This is related to the way serial ports get printed to. All right, and then I think I can get rid of this one, and now we can close that. And so now we might looks all right. Actually looks, oh yeah, it's just the head. All right, and then for fun, see what this comes out as. I also never ever remember the full syntax of read CSV, but it looks like it did exactly what I wanted. And so I'm going to just say plot x equals time s and y equals degree c. And if that works, we should, that's a bummer. Oh. All right, guess we will. I always hate giving these names too, but I also don't remember exactly how to do it every time, so let's see if this does what I want. That looks more like it. Okay, so besides my clumsy use of pandas, we have eventually achieved a goal of getting data from the Arduino into a file that we could then make a plot or do some, some other kind of analysis here, and so that's the main goal of today. Okay, so let me do one more thing here, and let me update this org-db update buffer. And I want to come back to this question of searchability. And so we have some ordinary text in here that's easy to search, but we also have these images and a video and an audio, and we're going to see what we can search out of those as soon as this wraps up. Might be taking a little longer than I would have thought, because it's taking that image that you can see part of and running it through an OCR program called Tesseract and saving that to a database. Then it's taking the video that we made, transcribing or extracting the audio from it and running the audio through a speech recognition tool and indexing that. And then it's also doing that for the soundbite that I made. All right, so let's check out images first. org-db images. Let's see what comes up under boat. None of those are coming up. Maybe I didn't do something right. Since last time, I've also created org-db audio, and this has a couple of things in it that I did before. Let me just update this buffer one more time. I thought that we would see those by now. But it's a little bit troubling. I don't see the screenshot here at all. And it seems to be stuck. So that might not be super good. All right. Okay, so that also looks like it didn't work. I don't see any obvious issues in messages, so my guess is that it just didn't do what I thought. But it probably should have. So next time we'll probably fix that. So I think I'm going to end there and go back up to, you know, the main idea today. Easy things are easy. It's easy to run a shell command, for example. It is not actually that hard to take a cell block here. So here I just created a new source block called Arduino, and it has some arguments that tell it what to do. Those get passed into a command line, and then I can take this code and run it directly on the Arduino. And I showed you, you know, here we could have screen capture. So this is actually a lot better than in years past, where I would have all of these notes but not actually have a picture of the device and layout and the circuit board. And down here we had a video, and let me just move this up to here where I meant it, and we can play this. All right, this is an audio version of #Arduino banana boat running the 3 LEDs with the temperature controller. That's all for now. And then we can play our video. Now I can talk, and I'm going to read the #Arduino banana boat. It's playing right here. That's also because I'm going to see later. Okay, looks pretty nice. And I showed you how to read a serial port. This is using Emacs. You can also do this in a shell, and probably there's something more clever to do than what I did in here. And move this down here. And then we looked at this data, read it, and plotted it. Okay, so that's all for today. Again, extendability, ability to integrate almost anything into your notebook, I think is absolutely essential for any electronic notebook. And if your notebook can't do that, then you just won't be able to do interesting things with other pieces of equipment eventually.